Hello everyone, welcome to another lesson on Three.js for beginners. The topic for today is gonna be lights. Okay, so right now in front of me I have an empty screen. So this is the setup that we're gonna be working with. As you can see over here, there's a GUI with label light on it, and here I have a list of different light types. If I click here, then we get a point light and it appears on the GUI, so I can move it around, can move its position, I can change its color and many other things. So the reason why I'm showing you this is so that you know what we're going to be creating, because it took quite a lot to create the setup to have one light at a time. So this is just code that I created to just manage the scene so that I only have one light at a time, which would make it easier to illustrate the different light types and what they do. So now that you've seen the preview, I'm gonna go back. I'm gonna go to our script and then we're gonna start coding afresh. Okay, so just to give you a heads up, I'm gonna leave the basic settings and then I'm gonna delete everything else, and so everything else we will create together, and I will show you how I created the entire thing. So this is what we're gonna start with. This will be our skeleton for our code base. So as usual, we will import our library and then we will import our GUI. So this time we'll also import a Rect area light helper. Now this is specifically for a Rect area light. So we're going to be using this to visualize our Rect area light so that we can be able to locate it in our 3D space, because lights are not visible in the scene. So this is something of a widget that helps us to see where our light is located. And then as usual, we will have our renderer. So this is the render setup. The only thing that will be different here this time around is in our renderer we'll have a render shadow map enabled in order for me to really show you everything that a light is capable of. Okay, and then we will have a perspective camera as usual. There we go. And then our scene also. Okay then, so I'd say let's just start creating. Okay, so the first thing that we're going to create is a cube alpha map. It's a texture. This is the connected dots texture that I've used in the previous tutorials, and this will be used to display shadows. So over here I will create our cube alpha map and I load it with our 3 texture loader, and then I will create our cube mesh, a setup that you're familiar with. Also I'll be using a mesh standard material, and then I'll give it just a white color with the wireframe on, metalness, so all of these settings. And then after creating it, then I will turn the shadows on our mesh. So I will say cube mesh.cast shadow equals to true, cube mesh.receive shadow equals to true. So all this means is that our mesh will cast a shadow and it will also receive a shadow from any other nearby object. The next mesh we will create is a background cube. This is what we'll be using as our background. Simple settings. So we want our background mesh to receive shadows, so that is true, but we don't want it to cast any shadows. Okay, so that has been turned to false. Then after that, then we'll add both meshes to our scene, so cube mesh and background cube mesh. Over here I will create a variable called light index. I will explain later what this will do. And then I will create an object called light types. This is the object that holds the lights. And then here I will create another object, and that object is called light helper types. So in here I have all the light helpers which go with the different types of lights. So you can see the point light helper is specific to point lights, spotlight helper is specific to spotlights, and so on. So just to also recap, the different types of lights that we'll be covering in this lesson is point light, spotlight, directional light, ambient light, rect area light, and hemisphere light. Okay, but I'll probably explain that again. But don't want to be too repetitive, but just to make sure that everything that I'm doing here is understood. Okay, so over here I've got a function, right? This is called add light helper. Okay, so just to explain what this function does, it takes a light as an argument, and what it's going to do is iterate through our light helper object over here, and then it will compare to see which value matches the type of light that we have in the scene, and whichever value matches that, then it will add that to the scene and then make that the light helper for the light that we have in our scene. Okay, so our light helper match is going to return true or false. So it's just going to check if there's a match. If there's no match, then nothing is going to happen. So here we have an if statement which will check whether or not we have a light object, so to check if that argument is null or whether it exists. And then it will also check the results for the light helper match. So both these conditions have to pass. Only then we can add the light helper into our scene. So next I'm going to create an array called light types list, and then I will iterate through our light type list object, and then I will push each and every key into our light type list. So this will be populated with the keys from our light types object. The reason that I'm doing it this way is also to save time because this is a complicated setup. So the point here is not really to focus on how I made this setup. I just created this just to make it easy for me to illustrate or to just take you through the different lights and show you what they can do. So I just want to get through it quickly. So this is not really the important part, but this is a lesson about Three.js, not about JavaScript necessarily. So I just want to make that clear so that you understand why I'm doing it this way. So the code you just copy as it is, and then we'll get to the exciting part, which is more Three.js content. Okay, so here we have a function called remove current light in scene. So what this does is it will remove any light that is in the scene. So how it's going to work is that every time I click on a new light, when I want to put a new light in the scene, it will check if there's a light type object in the scene. If there is, it will remove it from the scene and then add the new light. So that's what this does. Okay, as much as we have a remove current light in the scene, we also want to remove the light helper that is connected to that light. Okay, the next one is a massive one. Okay, here's another function. It's called add light property. So this one will take a light object. So whatever light is in our scene, it will take that. And here we make sure that the light object is not null. And if it's not null, then we check through the type. And so we check, okay, is this a point light? If this is a point light, then we add a GUI. So that's how that will work. So with the type of light that we have, then we add a GUI that has all the properties of that particular light. So that's what this code does. And as you can see, we have all the different GUIs that will be added. And that's pretty much it. Okay, so it might look a bit complicated, but it is actually not as complicated as it looks. So here we're just using an if statement to check if the light is not null. If it is in the scene, if we have a light in the scene currently, and when that's true, then we created a switch statement here, and with that we check what type of light we have. So that's pretty much it. So I'm just gonna, for now, I'll just close it down so that we have a bit more space. Okay, and then we add another function. This function is adding a light. So this is a function that's going to be adding a light into our scene. So how this is going to work is that it's going to get the value from our light type list over here. So how that's going to work is that this is going to be holding all the keys from our light type object, and so that's what's going to go in here. And so whatever value is in there, that's what our current light is going to be. So if that's point light, then point light will be our current light, and if that is not null, then the light will be added to the scene, and it will be positioned accordingly, and then it will be assigned a light helper, and then we will add then the properties of that light. Sounds simple enough, doesn't it? Yeah. Okay. So I will leave this open, but I will go through all of this again. So let's just see how it goes. Okay, I will try to make sure that at least you can see these values. I will also make it a point to make the code available. That's the least I can do. And so next, what I will do is these are just basic settings. Okay, this is just the camera position. So this is where I want to position it. After that, then we will create a GUI. Here's our GUI. After that, then we create an object, and this object is called light data. So this will be all the data for all the different types of lights. So this is all the data that the lights have. So we will use each one for the specific light that we have in the scene. Okay, and then we create a light folder, and that light folder will be called light. Inside the light folder, then we will add a light type list. So this is the list of lights that we can choose from. Okay, and this is the point light data set. So these are the values for the different folders that we will have. So at the moment each one is null, but whenever we have the specific light for that, then this will be assigned a value, which would be a folder in the GUI with the different properties. Okay, and then after that we will create another function, and this function is called remove light GUI folder. This will just remove the folder when we remove the light from the scene. So that's all that does. And then after that, then we will have a render function. Inside the render function, we'll have a camera look at. We just want the camera to look at the scene position, and then we just render the scene. Then over here we just have a rotation for our cube, and that's just the cube that's going to be in the middle of our scene. That's pretty much that. I mean, I could also swap it out and put it over here, but it doesn't matter, it works. And then next over here I will create another function called animate, and inside here I will call render, and then I will call the request animation frame, then call our animate function. So that is the setup that we have. So what I'm gonna do now is then go to our browser. Okay, so as you can see, this is our GUI folder called light. Here we've got light type. So here is a list of all the different lights that we can add to our scene. Start with the point light. This is just the positioning, so you can move the position. You're familiar with these settings. The point light has color, so we can adjust the color of our point light. We can adjust the intensity of it. We can also adjust the distance, so we can tell it how far the light needs to travel. So far away objects might not be hit by the light if the value is low. And then we can make it cast a shadow. We need to adjust our bias to minus 0.05 so that it looks proper. So there are our shadows. We've got blur samples, which we can then influence with our radius. So if we make it high, then you see we can just blur out our shadows, but you also have to be careful how you use this so that you also don't get these weird effects. But that's just pretty much how that works. And so we have decay. Now decay is also connected to the light, so if you want realistic light decay, then you have to put this on 2, use the value 2, and then you will get a more realistic effect. So you can see when I adjust the distance, this is what you get. So these two work together, the decay and distance. So this is a more realistic light effect. Okay, and then we've got I showed you blur samples. You can also adjust the map size, but I'm not gonna do it now because it looks weird. Depending on your scene, yes, it can work. I'd say 512 is a good default number to work with, but you can always make it into 1024 or whatever the case may be, but then you have to add other settings up. It gets a bit more complicated as you go, but just a basic light setup with 512 is good. Otherwise, then it's going to start doing things like this. But either way, you have the ability or the option to change the size, but it just looks weird and funky. So the next slide we have is spotlight, and we're going to move it up. So we can also once again move it side to side. You can also change the color. You can change distance, that also is tied in with the decay, so you can also adjust that. Cast a shadow. Once again, we have to adjust the bias. So if I bring the light down, you can see the shadow a lot better. You can see the shadow on the sides. So that's what our shadow looks like. You can adjust the focus of the shadow. Should be at least on 1. But yeah, this you can adjust it, but it's a bit weird sometimes. We've got your penumbra, so basically this just smooths down. You can see this edge over there. The penumbra is what makes it a lot smoother, so you can just, yeah, you have this, you don't have this strong contrast between lit areas and unlit areas. So you can also adjust the angle like so. So if you wanted to just hit a small spot, you can just adjust it like that. Make it bigger. And you can also adjust the size as well here, but like I said, with adjusting the size, it's a bit tricky. It can get more complicated. 1024. You see, now it just looks weird. But yes, either way, you have the option. Yes, so these are some of the challenges that you might have to face, like in terms of adjusting the settings accordingly. But 512, like I said, is a good default value to work with. Okay, so I think that's, we've also got this shadow camera value. So you can see you can also adjust that. Its influences more like the intensity of the shadow. If it's off, then that's what the shadow looks like. So yeah, yes, those are the settings or the properties for a spotlight. Directional light also has color. Well, they all have color. That's one thing that you can expect to always get. Well, I can just take it back to 1 once again. The bias should be fine. Let's bring it down. We wanted to catch shadows, so You can see there's our shadow over there. If I move up, then you can see it over there too. Okay, the radius makes it a lot smoother, almost like blurs it out. So I can also increase the blur samples. But that's what, yeah, that does. So it's quite similar to all the other lights too, and you can also adjust the size of it as well. But yeah, that is always a bit weird. Okay, the next one will be ambient light. Ambient light does not have a lot of properties, just the intensity basically is, yeah. Basically what you get. Well, that's actually a bit weird because yeah, what's happening right now is that because of the color of our, this is white, then you can't actually see. So let me just change that around. So there you go. So you can see it's green. And I'll just maybe make it red, or, but yeah, there's our, so that's what you get with ambient light. It doesn't really offer you much, but it's just basically color and intensity. Then you've got a rect area light. I can adjust the width and height of it. I will rotate it. So this part is the one that is lit, like that. Let's increase the intensity. So that's what that looks like. So okay, so that's what that looks like. I mean, you can basically adjust it. You can make it as big as you want. It has also intensity. You can adjust the size of it, and it has color. So that's pretty much what a rect area light looks like. Okay, so let's check out the hemisphere light. So that's what hemisphere looks like by default. Let's change the sky color. Let's make the sky color into blue. Actually, no, the sky color. Let's make the sky color blue. And then we make the ground color red. So it kind of mixes the color around, but what it actually does is that depending on the complexity of the geometry, then you can see the color more. So the top part would be more of a bluish color, and the bottom part would be more reddish. I will make the code available for the entire series. Well, this is nothing that you haven't learned before, so everything that's in here is quite straightforward, and I would say, yeah, that's pretty much it for lights. So the next one in line is cameras, and then we're done. Okay, without saying too much, love and peace, my brothers and sisters. I'm out.